Okay, hello guys. Today we're going to be talking about number-based system. Number-based system. Well, I would have just said I can just complete this topic and say number-based system of counting. Okay, yeah, that's exactly what we are doing. Normally, when we want to count using the Hindu-Arabic system of counting, we often use 0, 1, 2, 3. We use these digits 4, 5, 6, 7, 8, and 9. Okay, so when we use all these digits and do our counting, okay, when we are allowed to use any combination of these digits, we are counting in base 10. Alright, that's the base of counting. Because why do we call it base 10? Base 10 because we have 10 digits here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I write the number 989, okay, I can say that normally, okay, if I am not constrained to work in a particular base, this is in base 10, right? If I do 678, 854 and all that, all these are numbers, but they are in base 10. All right, now okay, so but there are some counting that requires that we don't use all the digits here to do our counting. I don't know if you get me. We don't use all those digits. All right, so sometimes we can want to count using only two digits, a combination of 0 and 1. Alright, so when we count using only 0 and 1, this type of counting is said to be done in base 2. Okay, that's base 2 counting. Excuse me. So that's base 2 counting. Now we can use 3 digits. When we use digits 0, 1, and 2, this type of counting is said to be done in base 3. Alright, so we can also have counting done in base 4. Alright, so let's say we are using the digits 0, 2, and 3. This counting is said to be done in base 4. Alright, so this keeps going on and going on and going on. Okay, so now, but what you should also know is that I can write a number. Okay, let me say for instance, I write a number 210. Okay, 210. Okay, let me add another digit 1 like this. And if I write this, I can write this base 3. So when I write a number like this and I write 3 down here, okay, or 2101 base 3. When I do this, I am saying that this number 2101 is in base 3. Or when I do this is in base 3, alright? So but this same number can be in base 4, right? Depending on what my convention down here. Or we can say 2101 base 4. Alright, so numbers can be in different bases. Okay, so whenever we write numbers that are in other bases, we indicate them. You can see we indicate them. But if the numbers are not in base 10, if the numbers are in base 10, we don't need to write the base. For instance, let's say 2101. If I just write a number like this and leave it up to you, then that means that this number is in base 10. But if I constrain it, I can write base 5. Okay, so that if you're doing anything, you have to know that this counting is done in base 5. And of course, in base 5, these digits are allowed. Now, let me show you something. If I write 3, 1, 3, okay, let me use something. 3, 2, 3, 2, 0. This number, and I write base 3. This is wrong, okay? Because in base 3, the digit 3 is not allowed. Excuse me. In base 3, the digit 3 is not allowed. So I cannot write 320 base 3. The only digits that are allowed in base 3 counting are 0, 1, and 2. Okay, so this should be a number in another base. Okay, so that's what I just want you to know now. Yeah. So now, just like we do addition and subtraction, multiplication and division in in base 10. Alright, we also do same in other bases. We can be required to do addition in base 2. We can be required to do addition and subtraction in base 2, multiplication and division. Okay, and the same thing applies to other bases. So what we are going to be doing in this learning spree right about now is going to be about how we can add numbers in other bases, and then how we can subtract numbers in other bases, and how we can multiply and divide. And then we also look at how we can convert from one base to another. We can actually convert a number that is in base 4. Say this number is in base 4. We can convert it to base 10. We can convert this. If this was proper, let's say this is base 5, we can convert it to base 10. If a number is in base 2, in base 2, the only digits that are allowed are 1 and 0s, like this. Any combination. Alright, so if a number is in base 2 like this, we can actually convert it to base 10. And if numbers are given in base 10, alright, we can actually convert it to any other base. And that's what we are going to be looking at shortly. Alright. Okay, so what we are going to be doing in the next few minutes will be on converting those numbers given in this basis to base 10. Alright, so we are going to start. Actually, the method we use for this conversion is called the expansion method. Alright, so all you just need to do is to observe what I do here. So I have 11011 in base 2. Okay, so if I'm going to convert this to base 10, alright, if I'm going to convert this to base 10, okay, let me write equal to, this is going to be 0, 1, 2, 3, and 4. Alright, so we give a place value in terms of 10 to the digits in this number. Alright, so we do 0, 1, 2, 3, and 4. Okay, because in base 10, alright, in base 10, this is like 1 unit, because when anything is raised to the power of 0, it becomes 1. Well, okay, let me not just go into that. Of course, this can be explained, but just know that whenever you have a number and you're to change it from one base to another, you start by designating the powers of this number as 0, 1, 2, 3, and 4. Okay, depending on how many digits you have in the number. Okay, so we start with this. So we are going to have 1 times 2, 1 times this 2 raised to the power of this 4, plus 1 times this 2 raised to the power of 2. This 2 raised to the power of 2, plus 0 times 2 raised, this is to the power of 3. Alright, 1 times 2 raised to the power of 3. 0 times 2 raised to the power of 2. Alright, because the 2 is on 0, so that's why we are raising it to the power of 2. Then plus 1 times 2 raised to the power of 1. Then plus 1 times 2 raised to the power of 0. So you see that. So this becomes 1 times 2 raised to the power of 4 is 16. 2 raised to the power of 4 simply means 2 times 2 times 2 times 2. That is 2 multiplying itself in 4 places. In 4 places. 2 times 2 is 4. 4 times 2 8. 8 times 2 16. So plus 1 times 2 raised to the power of 3. That's going to give us 1 times 2 raised to the power of 3 is 8, plus 0 times 2 raised to the power of 2. That's 0 times 4. Of course, from the onset, we could have done away with the 0. But we are just using this for an explanation purpose. Because all the zeros will eventually become 0. Then, plus 1 times 2 raised to the power of 1 is 2. Plus 1 times 2 raised to the power of 0 is what? 1. Any number raised to the power of 0 is 1. Okay, you just know that. We are going to handle that in our indices. Indices. So 1 times 16 is 16, plus 1 times 8 8, plus 0 times 4 0, plus 1 times 2 2, plus 1 times 1 1. So we add all this together. 16 plus 8 is 24. Alright, 24 plus 0 still 24, plus 2 26, plus 1 becomes 27. So you see that, so all this number in 1011 in base 2 becomes 27 in base 10. So I can write this 11011 base 2 is equal to 27 in base 10. So I can equally write 2 here in case you're wondering. I can write 2 here. Alright, so that's it for this. Okay, let's take the next one. And I believe if you follow the same approach with what I've done now, you should be able to do the next one. Okay, so the next one is 10010, okay, in base 2. So like I said, we just indicate their position with 0, 1, 2, 3, and 4. Okay, so it just so happens that I'm using the same number of digits, 1, 2, 3, 5 digits. Okay, so this will now become equal to 1 times 2 raised to the power of 4 plus, now you see this 0 and 0, I don't need them, so I don't need them, so I will go straight to this one. So I have 1 times times 2 raised to the power of 1. Alright, and then 0 times 2 raised to the power of is going to make everything 0, so I don't need this 0. So this will just become 1 times 2 raised to the power of 4 is 16 plus 1 times 2 raised to the power of 1 is 2. Okay, so 1 times 16 is 16 plus 1 times 2, which is what? 2. 16 plus 2 is what? 18. 18 in what? Base 10. So that means 10010 is equal to 18 in base 10. This is in base 2. Alright, so that's how this is worked out. Okay, let's go to the next one. Okay, you can pause the video and look at what I've done again so that you can understand. Okay, that's the advantage of this. You can replay as many times as you want in order to understand what we are doing. So this is 3, 2, 4 in base 5. Okay, this is a correct representation. 3 to 4 in base 5. This will now be the same thing we did in base 2. Here will be 0, 1, and 2. Excuse me. So we have 0, 1, and 2 here. So we start with 3 times, remember this is 5 now. So 5 raised to the power of 2 plus 2 times 5 raised to the power of 1 plus 4 times 5 raised to the power of 0. Okay? So 3 times 5 raised to the power of 2 is 25. So this will be 3 times 25 plus 2 times 5 raised to the power of 1 is 5 plus 4 times 5 raised to the power of 0 is 1. Okay? So 3 times 25 is 75, right? Plus 2 times 5, which is 10, plus 4 times 1, which gives us 4. So this becomes 75 plus 10 is 85, right? 85 plus 4 gives us 89. Alright, so that means that 3, 2, 4 in base 5 is equal to 89 in base 10. So that's simply how this is, okay? Simply how this is done. Right? Very simple. Okay, so let's go to the last but not the least one. The last but not the least one here. We have to convert 411 in base 6 to base 10. This is quite simple as well. All we are just going to do is to say 0, 1, and 2, right? So we are going to start with this number 4 times 6, which is the base, raised to the power of 2, plus 1 times 6 raised to the power of 1, plus 1 times 6 raised to the power of 0. 4 times 6 raised to the power of 2, 1 times 6 raised to the power of 1, 1 times 6 raised to the power of 0. So this becomes 4 times 6 squared is 36, plus 1 times 6 raised to the power of 1 is 6, plus 1 times 6 raised to the power of 0 is 1. So 4 times 36 should give us 144, right? 4 times 36 should give us 144, plus 1 times 6, which is 6, plus 1 times 1, which is 1. Okay, 144 plus 6 gives us 120. 120 plus 1 gives us 121 in base 10. So what that means is that 411 in base 6 equals 121 in base 10. Alright, so this is how we just convert from any base to base 10. That's what we have done. Alright, we converted from base 2 to base 10, base 5, base 6. Any particular base at all that it may be, we always do this, converting this from. Alright, so that's it about this. So we're going to look at if a number is given in base 10, how do we convert it to another base? That's what we are going to look at in few examples, and then we also look at some other things now. Alright guys, so we are going to be converting this number which is in base 10 to base 2 and base 3. To base 2 and base 3. Then we convert this guy to base 4 and base 5. Okay, actually it is very simple. This number, even if it's not stated, but it is in base 10. Okay, so for courtesy, let's write base 10 here, right? Okay, so let's continue. In this problem, we do this conversion using a method we call repeated division. Okay, we repeatedly divide and then we take the remainders. Okay, so if I'm going to convert 89 to base 2, I will use 2 and divide 89 until I am done with the division. Alright, so 89 divided by 2 is supposed to give me we'll go 44 times, remaining 1. Alright, so I take 2 again. Alright, I'm not taking any other number. 44 divided by 2 will give me 22, remaining 0. Alright, so I'll use 2 again. 22 divided by 2 will give me 11, remaining 0. So I'll use 2 again. 11 divided by 2 will go 5 times, remaining 1. Alright, so I use 2 again. 5 divided by 2 will go 2 times, remaining 1. So I'll now use 2 again. 2 divided by 2 will give me 1, remaining 0. Okay, I'm still using 2. 1 divided by 2 will go 0 times, remaining 1. Okay, so by the time I'm up to this point, I'll take this upwards. So that means that 89 in base 10 will now become, look at, I'm taking these digits upwards this way, will become 10110001 in base 2 now, because we are converting to base 2. You see that 10110001. Actually, you can if you convert this back to base 10, you're going to get 89. Alright, so that's it. Okay, excuse me too. Okay, I am going to have to check my work. Okay, so yeah, that's correct. So if you convert this back to base 10, you're going to get 89. Alright, so that's just it. So we are going to also convert to base 3, right? So let's go for base 3 now. I'm just changing this whole thing. Alright, so it's the same thing we do. We are going to use 3 here and divide 89 and keep doing that. 89 divided by 3 should go about excuse me, it will go 29 times. Okay, remaining 2. Okay, so I take 3 again. 29 divided by 3 should go 9 times, remaining 2. Okay, 3 again. 9 divided by 3 will go 3 times, remaining 0. 3 again. 3 divided by 3 will go 1, remaining 0. 3 again. 1 divided by 3 will go 0, remaining 1. Okay, so that's what we have here. So 89 divided by 3 is actually 29, remaining 2. Yeah, 3 into 29 will go 29 divided by 3 is 27. We'll go 27 times. We'll go 27. No, we'll go 9 times. 9 times remaining 2 as well, because 3 times 9 is 27. 29 minus 27 will give us 2, right? So that's it. So we are here. So 89 in base 10 will give us 10022 in base 3. Okay, 89 in base 10 will give us 10022 in base 3. Now this number is not called, I can't call this number 10,022 because it is not up to base 10. Alright? Okay, so that's it. So let's go to the next one and see what we can do. So we are answering the second question where we have to convert 121. So we have 121 to be converted to base 4. Alright, so 121 divided by base 4. 121 divided by base 4 will give us 121 divided by base by 4 will go 30 times, remaining 1. Okay, because 121 divided by 4 can go 30 times, remaining 1. Okay, so we take 4 again. 30 divided by 4 will go 4 times 5, 4 times 8, 32, 4 times 7. To go 7 times. Alright, 7 times, remaining 2. So we take 4. 7 divided by 4 will go 1 time, remaining 3. Alright, then 4 here. 1 divided by 4 will go 1 divided by 4 will go 0 times, remaining 1. Okay, so we take this upward. Okay, I did not do this in the other example. We take this upward this way, so that we are going to have 121 in base 10 to be equal to 1321 in base 4. You see that? So it's that simple. Yeah, I hope I'm very correct here. 30 divided by 4 will go, yeah, I'm correct. Yeah, I'm correct. Okay, so that's it. Alright, so this is correct. So we go to base 5 and then we check our work again. We convert this to base 5. So we are going to do base 5 now. Now you see, what this requires us to know, if you want to be good at this, you need to know your multiplication table very well, okay, and how to divide very well. Once you do that, you'll be good to go in this. So 120 divided by 120, divided by 5. Let me check something, please. So 121 divided by 5 will go 24 times, remaining 1. Alright, then we use 5 again. 24 divided by 5 will go 4 times, remaining 4. 4 divided by 5 again will go 0 times, remaining 4. Okay, so we take this upward this way. So 121 in base 10 equals 441 in base 5. Okay, let me use words. Okay, so that's it. Alright, so this is just how this is being done. When you want to convert from base 10 to any other base, this is the procedure to follow. Alright.